This is ACM ByteCast, a podcast series from the Association for Computing Machinery, the world's largest education and scientific computing society. We talk to researchers, practitioners, and innovators who are at the intersection of computing research and practice. They share their experiences, the lessons they've learned, and their own visions for the future of computing. I am your host, Bruke Kifle. Our next guest is an innovator, futurist, and artist with an interesting love for space dinosaurs, who believes in bringing crazy ideas and moonshot thinking to create future innovation. Pat Pataranutaporn is a technologist and researcher at the Massachusetts Institute of Technology, also known as MIT, where he explores the intersection of synthetic virtual humans and synthetic biology, specifically at the interface between biological and digital systems. He is currently a PhD candidate at the Fluid Interfaces Research Group at the MIT Media Lab and a KBTG Fellow, where he works with his collaborators such as NASA, IBM, UCSB, Stanford, and Harvard, amongst many others, to examine the future of human-computer integration. His interdisciplinary research has been published and recognized worldwide, and in addition to his scientific contributions, Pat's artistic projects have been featured at many museums and exhibits around the world. Pat believes in bringing crazy ideas and moonshot thinking to create future innovation. Pat, welcome to ByteCast.
Thank you for having me. Hello.
So I'd love to start off with a question that I ask most of my guests. Can you tell us a bit about your personal background and maybe a couple of key experiences or, inflection points, as I like to call them, within your personal and academic journey that have led you into the field of computing, but also your field of study today?
Yeah, that's a great question. So as you have mentioned, I'm a PhD student now at MIT Media Lab. And one of the reasons I'm here is that when I was in high school, and maybe we should go back a little bit further than that, I grew up really liking dinosaur. Dinosaur was a source of inspiration for me. Like many people, I think dinosaur has been sort of the reason why I study science. Dinosaurs all, extinct, but they're very, very cool and have inspired many of us to think about, what is out there, what is in the past and what could be in the future. I grew up, really liking dinosaur, and then I watched many science fiction as a kid. Many science fiction involved dinosaur, like Jurassic Park, or there's this anime cartoon called Doraemon, which is about a robot cat that help a child with different kind of tasks. And in that cartoon, the Doraemon robot will bring different kind of gadget, like time machine, take a trip to the past and see dinosaur, and also other kind of gadget that help improve human life. And what was really interesting to me is that, people often associate dinosaur with the past, but dinosaur to me is also a representation of the future, with new technological innovation, bring back the dinosaur, but it could also be dangerous as well. So it's like a cautionary tale of how to usually use technology for the positive application. So after that, I think that science fiction or doing something very cool with science technology would be something that I would love to do in the future. But I often think that it's only in the cartoon or in science fiction until I watched the TED Talk of my current professor at MIT Media Lab, Professor Patty Mars. She showed in her, one of the most famous TED Talk ever, that you can bring technology to the human body and create a real cyborg. And that, to me, was the moment that changed my life. I see that, wow, there are people that are actually doing really cool scientific work, but also, very fun and very futuristic, something that I only seen in science fiction until that point. And that's how I discovered the field of human-computer interaction. And I think that at that time, I was in the last year of high school. And I reached out to Patty, from out of my Gmail, I wrote an email to Professor Patty Mars of MIT Media Lab. At that time, I did not know that MIT professors are, the most busiest people on earth. And I reached out to her, and, she was so kind to write me back. And, I sent her a DIY prototype that I made in my high school based on the research that she presented in her TED Talk. And that's how we, know each other. And yeah, after that, I stayed in touch with Patty and then applied to her research lab and become part of her research group. And now I'm continuing that work on, human-computer interaction, wearable technology, things that are very futuristic, but also grounded in, real scientific research, and try to see if we can, really use the technology to improve human life. So yeah, to summarize it, it's, it started off as a scientific No, it started off as a science fiction. Not a scientific exploration at all. It started off as a science fiction obsession, a childhood inspiration, cartoon, and then that lead to real research at MIT. So that's sort of my journey. Yeah.
What an amazing life experience. I think many of us in tech, or at least I'll speak for myself, I was also very much interested in the field of science and technology, primarily because of, growing up, watching science fiction and, being fascinated by the potential of what could be. So it seems like that passion and excitement ultimately led to a real life career. So it's very exciting to see how that has ultimately manifested in the trajectory that you've chosen. One thing I want to learn a bit more about, you seem to be a very hands-on individual. I've seen some of your creations. So what ultimately led you to decide that a career in research, or at least going down the path of graduate school, was the right decision for you, as opposed to maybe exploring some of your scientific passions as an entrepreneur or as a maker? Why did you feel that, graduate school was the right path for advancing your career? I think your advisor, as you mentioned, motivated a lot of your interests with that TED Talk. So I'm sure that's a big piece, but I'm curious if maybe there are other motivators for your decision.
Yeah. Oh, yes. So my mentor definitely is my intellectual hero. It's one of the reasons that I pursue my graduate school. But I think, one thing that I really appreciate about doing research here at MIT Media Lab is that we get to sort of imagine the future. When doing my undergrad, I explored, a startup career and think about, what does it mean to, be a researcher and creating a startup. Then I realized that you need to focus on solving sort of immediate problem, and that's really cool. And there are a lot of people doing that. But for me, I feel like my strength is to sort of be more imaginative and think in the longer term, explore new possibility that haven't been explored before. And I think there is a lot of fun and a lot of impact in that. I think one of the reasons that the meetup is a really cool place is that we get to work in in a very interesting and emerging field. Sometimes we don't even have a name for that category. Like I think recently we start to call ourselves human AI interaction researcher, but that's really new compared to human computer interaction, right? So the field is self evolving, and we bring more and more discipline or more and more diverse background of people to work in our team, and that sort of expand our thinking in terms of what that area should be like. And in the media, we always say that we connect art, science, design, engineering together, and that usually not just lead to new answer, but also new question that we never asked before. And for me, that's really exciting. That when the research not just generating answer, but new question and new possibility for the future for us to think about.
Oh, wow, that's beautiful. I think the MIT Media Lab does a wonderful job of doing what you described, which is imagining the future and blending a wide range of disciplines, whether it be architecture and computing, whether it be biology and physics. So I noticed that even in your area of research, it seems to draw on many domains, from computing to biology, psychology, neuroscience. So how would you describe your area of study? I think you described it as the intersection of synthetic virtual humans and synthetic biology. As someone who may be new to the field or may not have much of a background, could you describe your area of study for me?
Sure. So our group is called Fluid Interface, and it's not about water or liquid. It's fluid in the sense of seamless interface between human and machine. And Professor Padima, my professor who lead this group, has been working in this area for quite some time now. And the idea of what fluid interfaces mean also evolve over time. It started off as thinking about how human can, actively receiving information from machines. So not just having passive machine that wait for us to sort of activate it, but thinking about recommendation or agent that can, recommend information to us. That I think is the first wave of fluid interface, create seamless an active information agent. And then that, is interesting. Patty had launched many startups because of that. And it has, changed the world. And then Patty was kind of a little bored with the idea that having this kind of active agent behind the computer screen. So it had led to the idea of maybe can we put this kind of, information agent on the human body. This area of research become what we now know as a wearable technology, right? Technology that are on the human body. People that, have started like Google Glass or VR, AR glasses, were part of that sort of era at the Media Lab. They call themselves, I think, the board, where they think about wearable technology on the human body. And then that right now is commercialized. You have smartwatches. Many companies, are working on that. And, recently we had like some excitement about the metaverse or the virtual reality. So many of that was rooted in that second era of thinking about human machine integration. And now I think we are in the third wave of what we call fluid interface, which is thinking about not just providing information on the human body, but provide what we call augmentation or enhanced capability, because we are overwhelmed with data, right? We don't just want to wear more glasses or any auto wearable devices just give us more data. We are already overwhelming with that. So how do we imagine new devices that not just throw information at us, but rather give us the ability that we want, like, ability to pay attention, to think critically, to be more creative. Going beyond information to augmentation is the new area that we are focusing on. We call it human augmentation, or rather human cognitive augmentation, to be more specific. So that is the newest or the third wave of fluid interface research. And that's, the area that particularly working on right now.
There's a very clear need for, the fluid interaction between, machines, technology, and humans. And I'll get a bit more into some questions around some of the limitations, but also future directions for, what you described as wearables. But I'll start off, I was reading a bit on some of your research, and I think one of the things that got me pretty excited was the clear practical applications of your work. I'm sure this is probably a result of the emphasis that, MIT Media Lab has on, practical applications of some of the research that folks are working on. You've been involved in various projects that use humans and machines combined to, improve learning, to improve well-being, to improve decision-making, to detect, mental health issues. I would love to start by learning about one of the projects, which I think is very interesting, which is human AI co-reasoning. What is it? We often think about the success of AI, or we optimize, the performance of AI as an entity on its own. What is this idea of human AI co-reasoning?
That's a really cool question. And I think that is one of the things that I think our group have been sort of exploring. I think in the past, we have been thinking a lot about how do we optimize AI on itself. Eric B. Johnson, who used to be at MIT, has really coined, I think it's a really cool term called the Turing trap. He said that, well, if, Turing is a really cool person and he has, create this amazing field of AI, but he also had led the trap for how do we evaluating AI? And for him, it's about how do we replicate human intelligence. Like if the AI can, trick us into believing it's an AI, then it has shown intelligence. But that by itself is a trap in a way, because you are forcing people to think about, okay, how can you use AI to replicate human intelligence? What he argued that I think is really interesting, and I think is a vision that our group is exploring now, is thinking about how the AI could augment human capability rather than replicating human ability. So instead of making an AI that are like us, can we create a new kind of AI that are augmenting us or complement our intelligence? And when we talk about intelligence, we are not just talking about one way of intelligence. We think about creativity and rational thinking. Sometimes it's the opposite of one another, right? Sometimes you want to be more creative, sometimes you want to be more logical. And in our group, we work on several kind of AI intervention that are augmenting our cognitive capability in different domain. The project that you mentioned, wearable reasoning or wearable or human AI co-reasoning, really explored the question of how can we use AI to help us become more critical in the way that we process information? As you know, we're living in the era where we have many misinformation, we have many fake news, we have a lot of information that are harmful to us. Can we use AI to augment our ability to process this information and teach us critical thinking? So in that project specifically, we explore a way that we can integrate an AI that is trained to pick up logical fallacy or picking up linguistic signal that can be the indicator of misinformation and put that in wearable device. So in the future, when people going around in their life or doing works, they would have this kind of AI integrated into a wearable. We call it like a second brain that help them process information. So that AI can give you sort of maybe like a whisper to you, like, oh, this information that you encounter is lacking evidence to support it. Maybe you should think more or do some more research before you believe in it. And this just, micro nudging we have shown to actually improve human critical thinking. interval of, people tend to be able to distinguish between information that is lacking any support from evidence or from argument that have support. And we also further demonstrate that the AI would work best to help people reason when it can explain its decision, like when it can explain to you why it made that decision or why it made that suggestion. So in that project, we also show that explainability and trying to have an AI that explains itself is very important for human AI co-reasoning. So not just that it need to help human reason, it also need to be able to provide the reason for itself. And that's sort of the area that we are working on. And right now we have expanded that to multiple domain. We are exploring that in the form of wearable, in the form of virtual agent. Maybe the AI doesn't need to be in your glasses or in wearable device. It can maybe show up on the screen. And we're thinking about what kind of personality, what kind of appearance it should show up. Should it show up as a Socrates, like Socrates, the Greek philosopher, like come and challenge you, make you think more critically, or should it show up as maybe someone that you like or admire? The appearance of AI has also been something that we sort of explore and thinking about. If we were to have more AI in our daily life, what are these social dimension that we should explore? The personality of AI, the appearance of AI, what kind of question it should ask you, right? This is the kind of interdisciplinary research that we are exploring, thinking beyond how do we optimize the AI, but how does the AI interacting with the human sort of change the way that we experience our life and the way that we will work in the future. So that's sort of the research we are working on.
Very exciting. I really like this idea of nudging. I've actually seen that employed across various domains, whether it be nudging on my smartwatch telling me to take a break or to stand up or to make sure I'm walking my number of steps for the day. Do you see, so are the primary applications that you're pursuing now for misinformation or fake news detection? Do you see other application areas, whether it be in HR, in health, it seems like the applications are very wide here.
Yeah, definitely. So I think one area that I'm particularly excited about is the idea of AI for education. Right now we have many powerful AI models, and they are really exciting, and many more researchers are creating more and more models, large language model, generative image model. These are very cool by itself. But thinking about how they can really improve the way that we learn is also really interesting. Professor Seymour Papert, who is a legend at the Meat Lab, said that we cannot think about thinking without thinking about something. It's a really powerful phrase to think about. But I think going further, we should think about how do we think with the thinking machine. When the AI are starting to have this kind of amazing capability of generating new information, can we use them to make learning, not just about critical thinking, but learning in general, more exciting and more fun? Can we use AI to really personalize the content to make the learning material be more individualized, or targeting the interests of each individual? Or can use this AI to allow children to be able to have like an expert opinion, like one of the projects that we work on the area of AI generated virtual human is thinking about, can we use this AI to create a virtual peers? Maybe if a kid want to learn about physics, maybe they can have a virtual Einstein that provide them with state of the art research in a way that they can understand. Or maybe if they don't like Einstein, maybe it could be a virtual superhero or any other character that is personalized and based on the student interest. And with that, right now, there are a lot of conversation about, should we ban the language model or should we ban an AI because it can answer a question, and children no longer need to write essay. For me, and I think in the media in general, we're thinking about, yeah, of course, new technology going to come in and it's going to challenge the way that we think about learning. Like maybe in the future, kids no longer need to write essay because AI can already do that. But together, can we think about new education paradigm where children with the power of technology can do things that even the teacher today cannot imagine? Maybe with the power of AI, virtual assistant or virtual learning assistant, children of the future, maybe at the age of, 5 or 10 years old, would already achieve something that a PhD student at MIT, 20 years old later can do. Can that accelerate the capability of people to learn and make amazing things? Like maybe children of the future will be able to cure cancer in middle school or something like that with the power of AI. So that I think is the exciting vision for the future. How do we empower learning with the capability of AI?
Yeah, I think
Yeah,
I certainly love this much more optimistic view. I think there's been a mix of response from both the computing community or the AI community, but also the general public. And it seems that most people are very quick to suggest that banning the technology is the right thing to do. And while I agree that policy and moderation is necessary, I think your viewpoint is certainly much more optimistic, which is how can we think of education of the future or students of the future where perhaps they're not spending their cognitive abilities on writing essays, but now they might be thinking about more critical world issues or thinking about how to solve
right,
some of the major problems that we're facing as a society. So it's very exciting to
right.
see that folks at the Media Lab are optimistic on how we can reinvent or think of a new paradigm for education using
Right.
these foundational models and technologies.
Yeah, one vision of the past, I guess, the philosophy of the past that I really appreciate is the vision that was led by Manfred Klein and Nathan Klein. These two people have coined the term cyborg. And it's in contrast to today's perspective that cyborg is about losing humanity and becoming more like a machine. In their original paper, they said that the idea of cyborg is to use technology as part of a human body, and it's not about becoming more like a robot. It's about becoming more human than ever. So you can use technology to do the things that is mundane and repetitive and like a routine job, so that human can be more free to think, to create, to explore, and to feel. And the term cyborg was coined in the context of the early era of space exploration. And at that time they're thinking that the space is so big, and we by ourselves, the biological body can no longer go into the deep space, right? So we need to augment ourselves with machine. But I think that idea of using machine to make us more human than ever, should apply to the way that we think about technology today. Or like why do we want to be like a robot? I think we should remain human, remain having our agency and freedom to explore things, and use technology to sort of expand that capability. I think we take that, we at the Media Lab, we are the sort of the optimists. We try to not just see technology as black and white, but the way that we can really empower people with new technology. So if we take that perspective and imagine what learning could be like. The universe is so big, we have so many questions that we are curious about, where we're from, what is out there. Learning should not be constrained by what we know, but what we don't know, right? If we can really empower children to play in the Media Lab, we think a lot about lifelong kindergarten, right? That's a really awesome group at the lab that really explore the future of learning. We think a lot about playful learning and constructionism, the way that we can construct new knowledge with the power of AI. I think that would really enhance or really accelerate the way that we learn and think about new challenge for humankind.
Certainly. I think any technology has limitations, or the advent of any technology has any negative use cases. But I think if we are optimistic, the positive impact that technology can have far outweighs any negative impact. So it's very exciting to hear some of the viewpoints that you have. I want to go back on the wearable reasoning project or device that you mentioned. We're speaking, or this is an audio conversation, so I can't physically see, or you can't physically show me what this device looks like. But can you describe what this wearable device look like?
Yeah, we have different iteration of this, but one of the recent iteration that we have is actually now exhibited at MIT Museum
Mm-hmm.
in the AI exhibit. So if anyone come to Boston or come to Massachusetts, I would encourage the audience to go and visit that. They have really cool. And they have not just our project, but many amazing projects from MIT that really highlight the evolution of AI throughout the history. And our project is sort of one of the recent example of what human AI interaction would look like.
Specifically manifest as a screen, as a device that you wear, like augment your vision. Yeah, I'm curious to learn a bit more about what the device
Right.
actually looks like.
Yeah, so there are different ways that we can, present an AI to a person. In that project specifically, we focus on audio interface or voice interface. Particularly, I'm really interested in the way that the AI could become sort of the second inner voice. Like when it whispers to us, can it be sort of the voice of reason, or a second brain that provide us with second opinion? So in that project is a glasses with audio and microphone and the Bluetooth capabilities, so it can connect with the computational power in the cloud. This is where the AI exists and process the information. And we try to make it, as I mentioned, make an explainable AI, so it can not just provide the feedback to the user like, okay, this is reasonable or this is not reasonable, but provide a meta analysis like, why does the AI think that this is reasonable, and see if that could improve human decision making. And we found that it was really effective in helping people discern misinformation from honest information. So that's what the current wearable look like.
Very interesting. Yeah, I've seen a range of responses to wearable devices. I think in sort of the first era of wearables, we've actually seen many limitations that led to, unfortunately, the failure of many moonshot wearable technology. I think you described some with, Google Glass, and now with the metaverse. There's usually high price. There's the physical inconvenience of the device. It's very obstructive to, your day-to-day activity.
Right.
It's heavy. There's concerns around privacy and safety. So when working on wearable devices, how do you think about some of these challenges? Is there a future to what wearable devices looks like to help address some of these concerns or pain points?
Yeah, that's a really great question. And I think it changed the social acceptance of wearable device sort of change and evolve over time as well. I think earlier people think that the glasses, would be the best form factor to deliver the information to the person, right? That's why we have so many glasses in the beginning. And now it seems like the form factor that seems to be more widely deployed is the glasses, right? I think one of the things that we think a lot about in terms of when we create new devices is that, can we piggyback on things that people are already familiar with, right? Like these two devices are based on objects that we have already encountered in our daily life, like the glasses or the watches. They had less computational capability in the past. Now we have new ability that we add to them. So I think the key to success for this wearable is to sort of think about ways that it can integrate seamlessly into our daily life. And of course, we're gonna see more evolution of that kind of technology in the future. But it seems that what people care a lot about is not just getting more information. As I mentioned, more information doesn't lead to productivity or improvement in terms of our ability to use that information immediately. We should think about how the technology really provide the value to the people. And our group have been sort of looking at the cognitive augmentation, but there are many other area like sensing. Can this device sense information that we never sensed before? Like right now, one of the trend for deploying wearable devices to use this kind of technology to do things that we used to do in hospital, like measuring high quality heart rate and respiration, and skin conductivity and arousal and other things, right? These used to be things that we do at hospital. Now they're become integrated into our small wearable that we wear. So I think there are many advantages that this technology will provide in the future, but thinking about what are the real values that that they provide to human, I think is really important. Not just taking for granted that having more information would be useful, thinking about what are the real values of having that information, or what kind of augmentation can come about from that information. I think that's the important part.
So to do that, do you find yourself speaking with potential users of the technology? Or do you have focus groups, studies that you conduct, maybe engagements with community? How do you better understand not just developing technology for the sake of developing technology, but for the purpose of, as you described, providing value or utility to the kinds of people that you're developing the technology for?
Right. I think that's an important question. I think in the Media Lab, we tend to be more imaginative. Sometimes we explore needs or challenges that are not a big issue today, but could be in the future. For example, we have been working on many space projects related to augmenting human capability in space as we become what we call interplanetary species, when human can travel across different planets. Which is it become more real than in the past, right? In the past, we tend to think of this as science fiction, but with the recent space race in the private space industry, we start to think that these will become more important in the future, especially if we're going to have longer space mission or deep space mission where we go into a further planet. And with human space mission, people tend to think about like rocket ship and spacecraft, but I think one important area is also the space health. How do we use wearable to really allow people to have like healthy lifestyle or healthy life in space? I think that's a really huge and important issue. So we have been working with NASA TRISH, a specialized unit in NASA that support the advancement of space health, and MIT Space Exploration Initiative, which is an initiative from the Media Lab that really think about how do we humanize the space exploration, how do we focus on the human aspect of space exploration. So we're working on wearable system like wearable lab on the body and wearable bioreactor that allow astronauts to be able to sort of sense new information from the human body and be able to provide intervention on the astronaut suit itself. Because when you're in space, you don't have the ability to go to hospital, right? There's no Harvard Medical School or MGH around. You need to think about what kind of medicine can you pack into wearable device or on the astronaut spacesuit, so that if you're sick, you can have that healing process or that treatment right away. So that has been an area that we work on, and that sort of work had led to a community actually called Space Chi. We have been hosting a workshop for the last 2 years at ACM Chi, which is the largest conference in the area of human-computer interaction. We have been creating this sort of spatial gathering for people that are working at the intersection of HCI, human-computer interaction, and space exploration. And in the past, it's just NASA people. We talk to many people from NASA who said that in the past it's just us thinking about this question of how do we augment or allow astronauts to live healthily in space or to be able to work effectively in space. But now many researchers are thinking about it. Many designers, many artists even are thinking about this kind of challenge, because space exploration has become more democratized and more people are thinking about how they want to define the next generation of human life in space. So it's really exciting. Yeah.
ACM ByteCast is available on Apple Podcasts, Google Podcasts, Podbean, Spotify, Stitcher, and TuneIn. If you're enjoying this episode, please subscribe and leave us a review on your favorite platform. Very interesting. So it seems like your focus or your research motivations aren't even just thinking about solutions to existing problems, but it's also identifying new problems that have not yet been clearly voiced or clearly formulated. I really love the work that you described with, wearables for health enhancement in space. Do you see this being applied for those who are on Earth? I think even beyond applications in space, maybe there are seniors or folks who may be receiving in-home care. Are there applications even here on Earth for some of this technology?
Right, definitely. So many of these powerful or advanced concepts, like the idea of cyborg, that has inspired early work on wearable technology, right? The media people call themselves the Borg. Yeah, was in the context of space exploration. And I think space exploration has some kind of, magic or some kind of powerful vision that really inspire new innovative ideas, right? If you're thinking about maybe solution on Earth, there are more practical things or things that you can deploy with lower cost. But when you're thinking about space, it really opens up your mind or the way that you think about the problem in a new way. So that's why many of the technology that we're using today, from GPS or even like microwave that we're using in our kitchen, these technology that we're taking for granted today, were actually developed in the context of space exploration, right? So as we think further into the future, sometime the research that we create for that sort of extreme use case, but eventually they will become more democratized and more accessible to other group of people as well. But thinking about that right now may not make sense because as I mentioned, there are other more practical solution, right?
Yeah.
So I think one of the goal of the Media Lab is to sort of always look at the new frontiers and searching for new possibility, things that make people question, like, why are you doing that? But then, once it reached the level of maturity that we would expect, it will have tremendous impact on human society. So I think that's our job, to be maybe less practical now, but more impactful in the future. Yeah.
Yeah, it's always crazy until you actually achieve it. So
Right.
I think pushing the frontier of science is certainly a
Right.
the return is certainly there. I understand one of your experiments actually recently was launched to the ISS, the International Space
Yes,
Station. Can you tell me
exactly.
about that? That's actually pretty awesome.
Yeah. As I mentioned, MIT Media Lab has a really cool unit called the Space Exploration Initiative that work across different groups in the Media Lab to explore. Our project in the Media Lab are always sort of crazy and out there and at the forefront, but many of them are targeting sort of Earth-based population or Earth-based user. The Space Exploration Initiative really pushed the Media Lab to the next level, where we're thinking about how can we deploy some of the things that we think about on Earth in space. And the project that you mentioned is actually one of the projects that built on top of the early work that I have done on wearable technology for astronaut. In this project, we are looking at how do we create biodigital system that allow us to control the growth of bacteria in space, so that we can use this bacteria to do multiple things: help recycle material in space, help recycle material in space, help us produce medicine, and do other things. So we have been exploring how do we create this automated bioreactor that is digitally controlled, but allow us to sort of understand and grow genetic engineer bacteria in space for human benefit. And that has been a really fun project to work on, and it was launched actually before New Year to the International Space Station. And this project is a really fun collaboration among many group that come together to sort of explore this. And now it just returned from space to us. We're gonna be busy analyzing the result in the next a month or so. And I think it's gonna really show new possibility on how we think about biodigital interface in the context of space exploration. Yeah.
Well, that's very exciting. I'd love to hopefully learn more about or closely follow some of the results. I don't think many folks can say their experiments have been launched to the ISS, so I think quite an accomplishment, and I'm sure the results will be equally interesting.
Yeah, when you work on space mission, it's always like you are in some kind of a science fiction or movie. You think about, okay, what's going on, what challenge do you need to solve. Like, I really love the phrase from the movie The Martian, right? You need to science out of the solution, you need to science your way out of the problem. I think that's really true when you work on a space mission. There's so many problems, so many challenges that you need to face, and when you fix them or when you solve them, your mission get to go to space. And and we all very excited about that. Yeah.
Very interesting. We talked about a couple different interesting things that you've worked on, and your research has been published, various journals, featured in various media outlets. You collaborate with stakeholders in academia and industry, with NASA, as you described. What is the impact that you hope your research will have on the future of human computer integration or human AI
Right.
interface?
I think of the impact of my work in three ways. So for the first level, I think of my work as showing a new kind of prototype or a new kind of artifacts, things that people would think, oh, why would you do that? Or things that people think that, oh, would never work. We will make the first prototype, we'll make that first attempt to show that this can be done. Maybe it may not be the most effective prototype or may not be the most practical things that you can use today, but it's the first step to show that is a possibility, so that future research can improve and work on that. So that's the first level, to show new prototype, new artifacts that really bring crazy ideas into something tangible. The second layer of impact, I think, is to really show an experiment, to show that, okay, the thing that we make have this kind of impact or this kind of improvement on human life. You can see some of this in the experiment we do on human AI interaction, or on some of the space project. We have real scientific experiment that we validate our work, and we have shown that it have improved our human life in into our decision, health, creativity, or whatever. To show the experiment, I think is really cool. And then the third layer is to really deploy this in the wild, to see if it really have impact on human life. I've done some project that was deployed during the COVID pandemic, the chatbot that help people retrieve certain information, or design of a project that look at how we can optimize the flow of people getting the vaccination. These kind of project maybe less futuristic, but can be deployed and really save human life. Like the chatbot project was used by over millions of users worldwide. side and the vaccination side that I co-design with people in my team have really accelerated the process of vaccination. So we don't focus on just practical things, but if we have a chance to really push that or do something in that area, I think that's also really impactful. So yeah, these are the three sort of way that I think of my contribution to the research community and to the world, basically, to offer new kind of crazy prototype, ask question and experiment on things that we never thought of, and finally deploy some of these ideas and solution into the real world.
That's awesome. And, as I said before, it's only, crazy, or it only seems impossible until you do it. And I think at the end of the day, I really always excited and fascinated by the strong emphasis on practicality, on, how does it improve human conditions? I think many technologists can be motivated purely by, scientific pursuit, or just the happiness or satisfaction that, comes with, pushing the frontier of science as we know it. But I think there's also another aspect, which is thinking about how can it be applied to improve society or human life as we know it. I really love your perspective or your take on things. And I think one of the things that I found quite interesting is that outside of, your scientific pursuits, you also bring a very strong passion and love for art.
Yes.
And many of your work has actually been featured, I was surprised to see, in museums and, galleries around the world. And from what I observe, as you describe, you also have, this entrepreneurial spirit or this entrepreneurial drive. You worked on projects before, graduate school. You've been working on projects with the COVID chatbot, as you described. You've co-founded various programs and initiatives. Can you tell me a bit more about these two passions, your love for art, and then also this entrepreneurial drive?
In the Media Lab, we have this four area that we often sort of describe the way that this thing connected. We call it the creativity cycle, and it's about how art can inspire science, how science can inspire engineering, engineering inspire design, and how new design will continue that cycle by inspiring new art. Right. So that's one of the way that we think about how creativity happen is when new discipline are collide and connected with one another. So I was fortunate to work with many artists that I collaborate with to really, explore the implication or the new question that can come about in terms of, artistic practice from my project. Because often when we work on really advanced technology, whether it's AI or space exploration, it's really beautiful, and in terms of the aesthetic of it, or in terms of the question that it bring about. And art, I think, is a way of asking question and be imaginative and exploring sort of the hidden question to that. So many of my artistic projects have been exhibiting around the world, and it has really opened my mind in terms of what this technology is really about. Sometimes it's about criticizing the work, and sometimes it's about opening up new way of being expressive. So for example, I've been working with a Thai artist, Kavita, on creating an AI clone of her to have a debate, so she can sort of be in the middle of two AI that is based on her own data, talking to one another and exploring, what would she actually do when she externalize, her mind into multiple AI that are debating on important issue. And that performance has been, featured in several museums, and, has really, not just, it's not just that I enjoy working with her, but it really opened up my mind about new research possibility in HCI as well, right? So it's not just about making art, but how art really inspire new research. And, it's not just artistic community. I also engage with, startup community and industry. That's one of the strengths of the Media Lab, right? That we get to have member companies, and they bring new perspective, new challenge for the industry to us, and we have the privilege to be more crazy and say to them that, oh, to your problem, we have these crazy ideas, and that is beneficial for both of us, right? Because for us, we get to see a new challenge, insight on things that we never thought of, and for the member company, they see new crazy possibility that maybe they never thought of. So that's always fun as well to think about how the work that we do can go into multiple channel, artistic output, or industry output, or so I think for me, my work is about as I said, augmenting human capability. And I want to be, expressive and use this work in many ways. One of my goals is to live an expressive life, to be able to express my idea and thinking in terms of research, artistic project, and solution for industry and startup, and social impact. And yeah, I think that's the kind of fun research ecosystem that I've really enjoyed at the Media Lab.
Oh, that's awesome. And so it seems like science and these outside interests or pursuits are not independent or mutually exclusive. Rather, they actually help motivate some of, your scientific pursuits and contributions.
Absolutely.
Awesome. One of the things that I loved in your bio is this idea of, moonshot thinking to, create, future innovation. So as someone who actually, believes this idea in, crazy ideas and this idea of thinking about the future, how do you find you are best able to channel, your creative or moonshot thinking? Do you have a specific process? Do you have specific frameworks? Do you like to go on walks? Do you think of these ideas when you're in the shower? Like where do you find you are able to be at your best when it comes to, really thinking about these crazy quote unquote ideas?
I think I say it many times, but I think that your question are very cool. And yeah, for me, I always think that innovation is never a straight path. It's never like you walk into an innovation and it boom and it become a world changing idea, or things like that. It's always like it's like a walk in the forest. You go and you see that beautiful tree, and then maybe it makes you think of something, and then you walk and then you see another tree, or maybe you see a dinosaur in the forest, and it's always like an adventure. And yeah, if you look at the history of how powerful ideas come about, it's never happened in the formal context, or the context where people are like, okay, I'm gonna make something. It's rather happening in the very unexpected environment or in a very unusual place. So for me, one of the reasons that I love to work in this different domain, like artistic project and industry project and research project, is that it really sort of make your mind flexible to think across different possibility. And so I think that's one of the things that I really appreciate about being in the media lab, is that I get to sort of be flexible and go into that different area. And the best, you asked about what is the best time to have that kind of crazy idea. Yeah, I think walking definitely really help. It help you be stimulated as you kind of walk through the environment. I love to walk in the park in the afternoon or in the morning to get sort of new ideas, and listen to like music that kind of put you in the flow state. And sometimes showering in hot water also really help. It's really help sort of, yeah. And what I find interesting is that it will never come to the thing that you expect. It always sort of go in a different direction, but then at the end, if you figure out the connection, it will be something powerful and awesome at the end. So yeah, as I mentioned, it's never a straight path. It's always it's never a straight path. It's always a complex and malleable kind of thing that you need to sort of keep molding it and keep pushing it and keep thinking about it, and then it will resolve into something interesting, I think. Yeah.
That's awesome. So there's something to be said about, oftentimes we explore solutions to solve problems, but sometimes we think about how we can apply existing solutions to be, applied to problems that we've probably never explored before. So,
Right.
you've worked on some cool applications of, wearables and machine learning for learning and well-being and decision making. So do you often find that, you find yourself identifying problems first and then thinking of ways where technology could be used to fix these problems or, provide a solution to these problems? Or is it the other way around? Or maybe you think about, these are the capabilities that we have today with large scale language models or wearable devices. And then you think backwards, or you reverse engineer and you say, these are the kinds of problems that now I can solve with this technology. What's the framework that usually drives more of your research or your new explorations?
For me, I think there's no like one formula. Sometimes you are inspired by the new advancement in technology and in AI, for example, like new models are always like fascinating to me. And sometimes you have like a vision of like, oh, would it be cool if we have this kind of thing? And what's this thing about it? Like, what are the ingredients that I need to put together in order to make that? Like, is it new model that doesn't exist, or is it new data set that I need to go and search for? so I think it happened in both ways. Sometimes you see some interesting ingredient and you want to cook something awesome out of that. Or sometimes you think of a meal like that you want to make, and then you think, okay, what are the ingredients that I need to go find in order to make that. So I think it happened in many ways. And sometimes it's about, sometimes people criticize, the sort of the futuristic work that we do at the Media Lab, at like, oh, you're creating solution in search of a problem, like you're not solving real problem. But sometimes that's what we need, right? We need to imagine new ways to live a life. And sometimes it's not about using technology to fix the existing problem, but rather to reimagine how do we recreate or reimagine that whole scenario altogether. And the lab have shown a really good track record of how do we sort of reinventing that. Like, for example, the early work on touchscreen, that, I think it's a very fun example to think about. Like when the first touchscreen came out from the lab, I think it was an architecture machine. It was the precursor of the Media Lab. But Professor Nico Prante, who was the director of the Media Lab, he said that he was heavily criticized for exploring the work of touchscreen. And the first touchscreen that came out from the lab was criticized that, oh, human hand is so messy. If you touch the screen, it's going to make the screen messy and dirty. No one going to ever use the touchscreen. Those are valid reasons, but the thing that we never imagined we could do with touchscreen, outweighed that small issue. So I think sometimes we don't know what the future going to look like. So we should keep exploring and explore new possibility, not constrain ourselves in one way of thinking, like, oh, I'm going to only solve problem, or, oh, I'm going to just create things that doesn't exist. But be flexible. Like sometimes work on things that are practical, sometimes work on things that are imaginative, and the two will feed off each other and make you become a more creative person. Yeah.
Certainly. One of my favorite sayings is that good players play where the ball is, great players play where the ball is going to be. So I think in pursuit of future problems, sure, they may not be the problems of today, but they are the problems of the future. And if we can proactively think of solutions or explore ways to address those problems, I think it's better for us as a society in general. So quite exciting to hear that. I want to conclude with open questions for you. One, what are some exciting developments or future directions that you see in your research that you're currently working on or that you're excited about exploring? I think you mentioned some things around education. I think you also mentioned some things around the excitement of, these large models. But are there any exciting developments or future directions that are keeping you up at night, so to say?
Well, so I often think of my work as a two sort of paradigm. One is about bio becoming digital, and another one is about digital becoming biology. What I mean is that as some of the project in space exploration really show that we can really program biological machine, like how we program digital machine. And this is about synthetic biology. How can we program bacteria and things that are on the human body itself to become like a digital mini microcomputer on the human body, right? And the other area is about how do we start to reimagine digital system as a biological system. So start to look at these large language model not just as computational system, but similar to like a biological neural network. Like we need to understand how the AI work in the same way that we need to understand how the brain work, and the complexity of the AI system today, I would argue, is kind of getting closer to the level of human brain complexity, and we don't have tools to really study either the human brains and AI model at the resolution that we need to really fully understand what's going on. The work on explainable AI is emerging, but we need more work of that kind, especially on large model that are very stochastic, and model that are very complex in nature. So we need to really learn from biology, using bio to create new kind of digital, and using new digital to create new kind of biology. I think it's a puzzling idea, but I think it will really open up the way that we think about computing of the future. And of course, for me, I think one of the themes that we discuss is is that technology itself is neither good nor bad. It's about how we really deploy it, and the way that we interface technology with human is not something that we can take for granted. It's all by design. My advisor said that you cannot just make an awesome AI and expect that when you drop it to a human population, they'll be able to use it immediately and use it in the right way right away. You need to really think about how these two can co-evolve with one another. It's also this is also a very biological concept, like how to system co-evolve with one another. So the interface itself is really important. The media philosopher really said that the medium is the message, right? So when we work on this awesome or exciting new technology, the interface, how it connect with people, is really something that we need to pay attention and design for. So we talk about large language model and many large AI models. They are really awesome and have many benefits. But that benefit will not happen if we just think about that system alone without considering the human psychology, without considering how the human would over rely on it, or how we can really decide to promote creative use and critical use of that technology. It's not going to happen because of the system. It needs to happen by design. So we need to pay attention to that. So I think these
certainly.
two areas, thinking about bio becoming digital, digital becoming biology, and thinking about how we create system or AI system that co-evolve with human in the longer run, in the longer term, are things that I think a lot about.
Oh yeah, as we continue to see technology being so widely adopted in every aspect of our lives, and especially with the emergence, or at least the growing emergence of AI technologies, I think exploring both research paths, I think, is very important. And I think as long as we have folks like you who are thinking hard about these kinds of problems, or hopefully we have more, I think we're all in good hands. So one final question I want to ask,
Sure,
for those in the younger generation who might be interested in the field of computing, what advice would you provide? And one thing I specifically want to ask about is, it seems like you've been able to balance, your passion for science with some of your interests in art and entrepreneurship. So how would you advise those who are looking to balance some of their scientific interests with their passions, whether it be art or music or sports, to best channel and fuse those interests together as much as possible?
Right. And dinosaur as well. Yeah.
And
I think,
dinosaurs, of course.
yeah. I think, to me, what I've learned and seen at the Media Lab is the celebration of diversity, and diversity in broader sense possible. Like, you see a lot of interesting and weird people at the lab, and they all really show their unique perspective and unique appreciation of things. And I think that would lead to a creative community when people can really bring what they're passionate about to their work, and that passion will spark ideas and imagination in other people. So that kind of energy is really important. So not to kind of constrain yourself to becoming a kind of flat dimension or a one-dimensional person, but really celebrate who you are as a human being. If you love dinosaur, then go for it and bring that to your ideas and creativity. So that I think that's really important. And one thing for me that I think is also really important is to sort of think about what kind of impact that you want to have in the future. One of the Media Lab professor, you probably know, Professor Hiroshi Ishii, always asks all his students and other Media Lab students, like, what kind of impact would you have 200 years after you die? And I, of course, don't have the answer immediately, but it's something to think about, to have like a bigger question or something that is bigger than life, to think about, whether it's a philosophical question or things that make you don't just stuck in the moment, but be more transcendent in terms of your thinking. I think that's also really powerful. And I think finally, to embrace all the complexity of the world. Like, we are living in the era where technology is moving at such a rapid rate, and we need thinking from and all kind of thinking, not just scientific thinking, but artistic thinking and all kind of creative methodology to really help us understand how we're gonna live in the future. And it's not just about dystopia, and it's not just about utopia. It's about the mix of all the good and the bad and the negative and the positive. So exploring all the spectrum with embrace all the complexity and all the possibility ways and ways to understand it. I think that's the way of the future. People often ask me, like, oh, am I going to be replaced by AI, or am I going to be replaced by robot? And I think what is really powerful is to think about, we talked about this earlier about education, right? To not think about technology just as tool that replace human, but things that can really allow us to think of things that we never thought of before. The augmentation, the idea of cyborg becoming more human than ever. Children of the future will definitely experience this more. They should not be afraid of it. They should, think critically about it. But then at the end, think about what can we invent to really, uplift humanity. One of my friends has said that to imagine a dystopia is easy. It's easy to imagine how the world to end in many ways. Could be alien attack, climate change, whatever. It's easy to imagine the dystopia, but to really imagine how we're going to make it, how we're going to really turn the scenario around, that is the challenge that we as a researcher, scientist, artist, designer, engineer, whatever we are as a person of the future need to really think about. Be optimistic, but also critical at the same time.
With people like you, the future is bright. And I've certainly taken good notes on some of the advice that you've shared. So, I really enjoyed this conversation, and I look forward to seeing many of the great contributions you will have and will continue to have in the long future. So thanks so much for joining us on ByteCast, and look forward to keeping in touch.
Thank you for having me.
ACM ByteCast is a production of the Association for Computing Machinery's Practitioner Board. To learn more about ACM and its activities, visit acm.org. For more information about this and other episodes, please visit our website at learning.acm.org/BYTECAST. That's learning.acm.org/ByteCast.